place we know of where building a floating city above the clouds actually amounts to the best chance we'd ever have of living there: Venus. For all its pretty obvious flaws on the surface, Venus is also Earth's planetary neighbor, at times closer to us than even Mars ever gets. So if we could work out how to live there, we'd be one big step closer to spreading out across the solar system. And here's the thing, the higher levels of the Venusian atmosphere are actually quite friendly to human life. On the ground, it's all blistering temperatures and choking carbon dioxide. But that extreme greenhouse effect is thanks to the CO2 being trapped beneath a thick and dense atmosphere higher up. And it's here, in this thick and dense atmosphere in the Venusian clouds, where breathable air is also a lifting gas, that scientists think humans might be able to survive. But before all of that, could we work out the logistics and mechanics here on Earth? And will we ever need to? One reason why we might need cloud cities is that our cities, as they are, aren't always all that permanent. And some of our largest metropolises are actually sinking into the ground. Parts of Manhattan in New York City, for example, have reportedly been sinking for decades, while other cities with similar issues include Jakarta in Indonesia, Venice in Italy, and Bangkok in Thailand. Sinking cities is one problem we'd be without, though, if we moved to the skies. More than just solving our current problems, however, in a sci-fi style far future, floating cities would also represent a major advancement for humanity as a civilization. They'd provide us with effectively a pit stop to the stars, or at least to various satellites in near-Earth orbit, bringing more people much closer to outer space. In general, we'd no longer be limited to just the land we currently depend upon, and Earth's rising population would have more room in which to spread out. But could it ever really be done? We'd certainly need to make some major technological improvements. Currently, the best tools we have for lifting heavy objects into the sky are rockets, which have obviously proven fairly effective for us so far, transporting relatively small-scale payloads into space. With enough of them, you could theoretically lift anything off the ground, even a whole building. But it's not exactly a practical strategy, or affordable, or in any way sustainable, with hundreds, even thousands of conventional rockets needed to lift just a single city component, like an office block, or a stadium, or even just a public restroom. Consider then that even as we use them now, rockets burn through a huge amount of fuel very quickly. SpaceX's Falcon 9 uses $200,000 worth of fuel every single launch, for example. And you'd essentially need a constant, inexhaustible supply of rocket fuel to get a city airborne in this way, which just isn't happening. There are also the many dangers to think of, with one malfunction in just one of our hypothetically city-supporting rockets potentially causing an explosion and chain reaction which could destroy the entire city above it. And finally, there'd be the problem of pollution, not least noise pollution. Anyone on or close to our rocket-propelled city would basically be living next to a space launch 24 hours a day. And if anyone or thing was unfortunate enough to live directly underneath it, well, their prospects for survival would be close to zero. It's lucky then that rockets aren't the only option, in neither science fiction nor science fact. Sure, we would need rockets to get to Venus, but upon arrival we could switch to something else, something like balloons and airships. With airships, while we have reason to be optimistic, there's also long-lasting cause for concern, wrapped up in the story of just one vehicle, the Hindenburg. The Hindenburg ranks as the largest airship in history and had a capacity of 50 passengers plus crew. But it's also emblematic of all the problems that airships pose after it ignited in a horrific and infamous disaster in 1937. Not every airship is automatically as flammable as the Hindenburg was, though, with a major factor in its demise being that it used hydrogen gas as fuel. A switch to helium would significantly lower the risk, however, and we know that Venus has stores of helium ready for us to tap. If we were to get to Venus then, and somehow survive long enough to build them, then helium ships would be an option. But better than that, as more elements are lighter than the CO2 clogged air on Venus, there are more options on Venus for lifting gases than just helium, including breathable air, made up of nitrogen and oxygen. Unfortunately, here on Earth, breathable air isn't a lifting gas and helium is expensive and rare, to the point where there isn't enough available for us to even begin to be able to lift an entire city. So, as with rockets, airship cities in reality just aren't viable. Perhaps then, we should explore the potential technology of the future. Right now, we can't build floating cities, but someday soon we might, with tech that hasn't been invented yet. And one of the main players in this field is anti-gravity. Various people and groups have been trying to develop anti-gravity for a long time now, but despite many claims, there remains no credible evidence that it exists. For others, though, the key could lie with antimatter, which is the opposite of normal or baryonic matter. Unfortunately, apart from its general definition, we don't really understand much about antimatter, and we've yet to prove whether it also inverts gravity. We have just about managed to create antimatter atoms in a lab, but we haven't observed whether they're repelled by gravity in the way that normal matter is attracted. At this stage, most predictions are that they're not, so it's unlikely we'll be utilizing anti-gravity technology, at least in this form, anytime soon. And if it's ever going to be an option for propping up an entire city, we're going to have to make not just a few technological tweaks, but whole fundamental changes. But let's not run before we can walk, or fly before we can float. We needn't go from 0 to 100 right away, so building a floating city needn't mean transporting structures as substantial as the Eiffel Tower, or the Golden Gate Bridge, or the Burj Khalifa into the sky. A sky city would just have to be a lot smaller than a conventional city. And in a race between anti-gravity, rockets, and airships, advanced future versions of airships, appear the most plausible option. If we head back to where we started, to the clouds of Venus, a Venusian colony made up of just 2 or 3 of these ships could potentially house more than 100 astronauts. It's not a city by our current understanding, but then this wouldn't be city living by our current understanding either. Home for these astronauts would be a series of aerodynamic airship cabins, and due to the general toxicity of Venus, meaning that commutes between ships would need to be avoided whenever possible, everything would need to be housed in one place. Food, water, and places of work all under one roof, miles up in the sky and months away from Earth. Compared to what we're used to, it'd feel more like a commune than a city and extremely isolated. Somehow build a similar setup into the skies of our own planet, and the first few Sky City inhabitants would certainly be pioneers, prepared to accept the loneliness of their lives for the sake of progress and for some spectacular views. But comparisons could also be drawn with those who currently man the International Space Station, and before long, one airship could become 2, could become 5, could become 10. But that's only if we find a way to facilitate such an incredible venture, and right now, it's definitely more dream than reality. Rocket fuel is too expensive, impractical, and environmentally devastating. Helium on Earth is too rare and expensive, but on Venus it, or other lighter-than-air options, could be available. And anti-gravity, well, it doesn't even exist yet. But that's how we could build a floating city.